Hey, Reeb. Oh, I cannot hear you. You're on mute.
Okay, now I'm here.
You got it. How are you doing?
I'm doing well. Nice to meet you.
Good to meet you too.
Um,
Where in the world are you?
Currently, I am in a hotel in Manhattan.
Nice.
Yeah.
Where are you normally?
Normally I'm in San Francisco.
Okay, fair
Yeah,
enough.
yeah. How about you?
I'm in Halifax, Nova Scotia.
Nova Scotia. This is the first Zoom I've ever taken with somebody from Nova Scotia. Congratulations.
Nova Scotia. Yes. I used to be able to say land of no COVID, but can't say that anymore as of like a month or
It
two
got,
ago.
don't worry, now Manhattan is the land of no COVID. Everyone's walking around here eating indoors like it doesn't exist.
They're just pretending, huh?
Yep. It's just that's just how it's going over here.
Perfect.
Cool. I know I was supposed to meet you 10 minutes ago, but since I'm here now, is there anything
Well,
we need to chat about before we get started?
oh no, I think we have 22 people registered, so we'll see. Probably that means like 12-ish, 14-ish show up. And we'll record the event so that people can check it out in the future. In other words, on your end, so I think you were saying the talk itself would probably be like 15, 20 minutes.
Yeah, it should be pretty short. I mean, I haven't actually
Cool.
run through it yet, so this will be we'll be testing it live. But yeah, it should be
Perfect.
about that long, and then we'll just mostly do Q&A.
Sounds great. Yeah. Yeah. The group tends to be pretty curious, ask lots of questions. So yeah,
Good,
should.
good. That's what I'm looking for. That means less
Yeah.
work for me and more just answering things on the fly.
Yeah, I'm excited for it. I'm actually going in kind of blind. I wish I had a chance to really look into to Glacier. But yeah,
Well,
I'm excited to.
it's tough to get in here not blind because we have very little information about us out there on the internet. So um,
Yeah.
I think everybody here is kind of joining blind.
Fair enough.
Yeah.
Hey, Austin.
And mysterious phone number.
Yeah, and mysterious phone number. Welcome.
Welcome to
Um,
the
yeah, I'm excited. All I know is there's robots, and I love robots.
and there's climates.
Yep, that's
What a
important too.
confluence. That's
Definitely. Hey, David. So we'll probably give it maybe like 5 minutes, let people trickle in. Um,
yeah.
yeah. In the meantime, do you want to give us? I don't know if you have this planned for the talk, but I'm just curious, like how long you've been working on Glacier and what the story is there.
That you know what that is. That's the first thing I talk about.
Okay, so I will not ask you that.
And give a sneak preview. The answer is 2 years, and I used to be at Facebook.
Right. Interesting.
Sneak preview. What about you? What's your story with work on climates?
Yeah, so we started work on climate back in September. There were 8 of us. Now we're up to over 2,300, I think, which is really neat. And yeah, it started with the two founders, Cass and Eugene. Have you met Cass and Eugene?
Only via email.
Okay. So they were senior Google employees, and they basically started reading up on climate, realized what a mess we're in, and they spent a year just not knowing what to do about it until they met each other and convinced each other to drop out of Google with no plan whatsoever, to do something about climate. And they wrote some social media posts that went semi-viral with just comments from other Google employees being like, "Hey, we wish we could do the same thing. We'd love to quit work on climate full time, but we just have no idea how." And so the community was really founded on that need that there's so many people out there who want to be doing something about climate change, but they're not. And there's so many reasons why they might not be, right? Like maybe they just don't know what to do. Maybe they don't have the right connections. They haven't met their counterpart to quit and do something about it. Or maybe there's other issues. So basically, we try and unblock those issues. And it's just a shame if people want to be working on climate change and they're not. It's such a waste. So
Yeah, for sure. I think that's like one of the, I think when I was getting started with Glacier, that was kind of one of my like secondary objectives was
Yeah,
sitting here, well, not currently, but typically I'm sitting over in Silicon Valley and I'm amidst all these like giant, really talented tech companies full of really like smart people working on problems that like,
yeah,
range from the mildly useful to like the totally useless. I'm fully aware that when I was at Facebook, I was certainly on kind of the further end of that spectrum.
totally.
It's like, yeah, even if you well, I think two things. Like one, if you do want to work on climate, there's just like not very many options out there. You can scour, job boards or whatever, and like you're inundated in like here are like the Ubers and the delivery apps and the dating apps and the
Right.
like all that sort of stuff. Is like it's hard to find the climate stuff in there, and so it would just be great if there was more. And if you were graduating from undergrad, you're like, I want to be a programmer. Let me go find a tech company in climate.
Yeah.
And it was easy to do that. Or you're like, I just want to go work at a great tech company, and like somewhere on that top 10 list, 3 of the 10 or 5 of the 10 are like climate companies. That'd be a great place to get to a society. And we're certainly not there yet. So I very much appreciate the efforts.
Yeah, I mean, I'm a mechanical engineer, and when I was going through school, we had our internship programs, and all the job postings were like half oil and gas, to be honest, and like nothing to do with climate whatsoever. So
For sure.
yeah, I think it is changing though. I think like you guys and a bunch of other startups are popping up, so it's definitely changing. But I think you've been talking with Jeremy,
That's
and we're both helping out with the Google alumni community, and they have a Slack group over 9,000 people,
mhm.
and they have a climate channel, and out of the 9,000 people, the climate channel has maybe like 100 people, and we saw when the Australian wildfires were all in the news. Um, there was a ton of commotion in the community, being like, "Oh, we're Googlers. We have all this experience. Well, what can we do about this?" And no one had any ideas, and it just kind of like fizzled out. And there's so much potential there, and so how can we harness that potential and put it to use?
Yeah, definitely. Definitely. Well, I'm glad that you guys are doing what you're doing to help take our first step at harnessing that potential. I think we're probably getting to the point where we're going to not get too many more people. So I guess we can start segueing in. Did you have anything you wanted to say before we dive in?
Yeah, let's me. Yeah, you're right. Let's just get started. I'm excited for this. Looking forward to it. So hey everyone. So welcome to this talk with Arib. This is an event hosted by the Work on Climate community. I'm pretty sure everyone here is in the community already. If you're not, I encourage you to join us at workonclimate.org. We have a highly active Slack channel, and we have a bunch of programs to help people pivot and advance their careers in climate. So my name is Sam. I'll be facilitating. If you have any questions at any time, feel free to drop them in the chat. And I'm just really excited to have Arib here, because I know that there's a ton of challenges facing recycling. And I honestly have no idea what Arib has in store for us, but I know it involves robots, and I love robots, so I'm excited for it. So I think, Arib, you were going to give a short 15 to 20-minute presentation. We'll open it up for questions after. We'll try and keep it really interactive. And then I guess as two final notes, the event will be recorded and posted on the Work on Climate YouTube channel for anyone who misses it. And I have a notes document, and I'll be taking notes on the talk. And I would really appreciate some collaboration on it, because I am not very good at doing two things at once. But it's basically a common notes document. I'll try and take notes during the talk. But anyways, Arib, with that, I will let you take it away.
Cool. Well, it's awesome to see a bunch of people joining on. I know this is a very random talk, but even having this small group of people just kind of shows that there is interest in this problem. So I'm excited to have a bunch of people here to listen. As Sam mentioned, I want to keep this interactive. I know it's a Zoom call. It's kind of hard to interact, but like if you do have questions, feel free to pop them in the chat, or just unmute yourself and talk away. There's not enough people on here that you should be worried about unmuting yourself. And yeah, we'll dive right in. As mentioned, my name is Arib. So a quick background about me. Oh, Sam, I need screen sharing.
Oh, let me fix that for you.
Sorry.
Should work now.
the most common way that Zoom meetings start, right?
Pretty much.
Cool. So let me just get to present mode. Awesome. Yeah, so a quick background on me. I graduated from Cornell back in 2013, came to Facebook to be a generalist software engineer. I spent about 5 years there working on, this and that product, this and that tech stack at Facebook. And around that 4-year mark, I got this itch, this realization that there were some real problems out there in the world that needed people's attention, people's investment. And I was not doing my part in my heart to actually work on things that mattered, specifically, of course, climate change. And so I took a look around. I looked for areas that I could kind of jump into. As you guys may know, there's not a lot of companies out there that are like solely focused on climate change, and a lot of the talent gets sucked into companies that are just doing other things. And so, long story short, found this really cool opportunity inside recycling, a space I had not known anything about or done any research on prior. But then it turns out to be quite a remarkable space. So I'm going to go through and kind of share a little bit with you guys about recycling, how it works, what the challenges are, what we're working on, etc. And yeah, that's kind of what we'll be doing. My story at Glacier started 2 years ago. I quit Facebook after I had discovered that there was, a bunch of opportunity inside the recycling space. Have been working on it for 2 years. We're currently a team of 5. We just closed our seed round, so we're looking to kind of grow and get some stuff done. And I've been kind of leading the charge on this whole thing, and it's been a cool ride. But let's dive into a little bit more about what is happening in recycling. So just lay of the land. I think a lot of people here have kind of seen the articles. They kind of know that recycling just isn't in good shape, or rather the bigger statements, how we as society handle our waste isn't in good shape. So much so that every year we throw $123 billion with a B worth of our recyclable commodities into our landfills, into our oceans, into whatever, because we don't have the recycling infrastructure to handle it. What this means is the economics aren't in place. What it means is we don't have the infrastructure to actually retain, and so therefore people litter. What it means is we don't have the infrastructure to properly sort, and all of this leads to a lot of pretty nasty environmental impact. Obviously, the top one is pollution, right? It's what we see. It's the Great Pacific Garbage Patch. It's pollution on our roadways. It's burning of our trash because we don't know what else to do with it. It's landfills. There's a lot of pollution that comes from the fact that we consume a lot of stuff, and there is no system designed to handle what happens when we're done consuming. But on top of pollution, there's a lot of other stuff. So there's a lot of greenhouse gas emissions caused by the fact that we do not recycle properly. We do not handle our waste. The reason for that is simple. When you make a new bottle and you have 2 choices, you're going to produce it from the virgin stock, or you can produce it from recycled stock. TLDR, when you produce from virgin, it takes more energy, and therefore you emit more greenhouse gases, you burn more coal, whatever, to actually produce that new bottle, that new can, that new cardboard box, than if you had done it with recycled. The most shocking thing is if you have an aluminum can, it's 97% more energy and efficient to produce from virgin stock than it is to produce from the recycled aluminum can. And so it's wins like that we could be making, but we're just not, because we don't have the infra to handle it. Obviously, plastic is a derivative of oil. So as long as we are producing plastic from the virgin stock, that is producing it from oil. And that's a reliance on oil, which obviously we as a society need to move away from. And then just generally, anytime we're producing something from new material, that's going to be cutting down our trees, mining our ore, whatever it might be. And that's a depletion that we need to, as a society, just get past, because we want to be sustainable. There's a lot of reasons that we need to fix recycling. There's a lot of ways we can do it. And that's, I think, why everyone's here. But I think before we kind of get into how to do it, it's really important to understand how recycling works, because I know that when I started this, I really just thought you put your stuff in the blue bin and then magic happens and out the other side comes new stuff. Of course, it is more complicated. Quick TLDR, you, the consumer, the business, whatever, you put your stuff into a bin and you leave it on the curb. A hauler, this is the trash truck, they come and they pick it up and they take it over to what's known as a materials recovery facility, or a MRF. These are large facilities with conveyor belts, machines, people. Basically, their job is to take in everything they just received and sort it into individual commodities. So they want to basically create big mountains of aluminum cans, of PET bottles, cardboard boxes, what have you. That sorting challenge is obviously really intense because you're dealing with an entire city or an entire county's worth of trash, and you're constantly just churning through and trying to output stuff. What they do with that output pile is they sell it to a reclaimer. This reclaimer buys a bunch of basically plastic bottles and they chip it down. They clean it, they peel off the labels, they chip it down to what's known as pellets. Obviously, if it's a paper, it's cardboard, if it's aluminum, etc., the output changes. But they basically take the input, which is what's something you consumed except crushed up, and they produce something that they can then sell to a manufacturer. This manufacturer is that person I mentioned at the beginning who has the choice of producing from virgin or recycled. Well, this produced from recycled is buying from the reclaimer the pellets, the fiber, whatever it might be, and then they create something. In the ideal world, right, you throw away a bottle, hauler takes it to a MRF sorts it from everything else, reclaimer chips it down, and manufacturer creates one new bottle from that original bottle. Of course, there are a ton of inefficiencies along the way, and there's also a lot of challenges outside of inefficiencies that make this difficult.
Quick question. Are the MRFs and reclaimers always separate, or are they sometimes integrated?
We do not have any MRFs and reclaimers that are the same today. It would be a cool thing to have. One thing that's kind of not shown in this drawing is each of these blue arrows is transport, and transporting stuff costs a lot of money. One thing that I think a lot of people are hopefully familiar with is that the reclaimers, at least 3 years ago, used to be in China, and the MRFs used to be in the US. We used to ship all of our recyclables to China. China recently got fed up with this because we were essentially sending them really low quality stuff. We would say, hey, here is 1 ton of PET. They would get it and then be like, hey, this is like 70% PET and 30% other stuff. This is essentially garbage. We can't do anything with this. And they wouldn't know what to do. So they said, no more of that. We only want really, really high quality stuff. So high quality, in fact, that none of our local MRFs or any MRFs really in the world could produce that level of quality. And so China essentially became not a buyer for our MRFs. And we essentially had to figure that out on our own. But yes, these reclaimers are separate from the MRFs. There's transport involved. That transport obviously adds additional greenhouse gases. Again, the ideal kind of future state is consumer recycles, magic bin turns it back into a new bottle, and it doesn't go anywhere, right? That would be great if Whole Foods just did that, but we got to work. We'll do a little bit of work to get there. Any other questions on this? Cool. So yeah, big space, a lot of players, but what this means is that there's just a lot of challenges. I mean, this is the type of industry that it's really exciting to be in as an innovator, as a tech company, because there are a lot of challenges with a lot of potential to be solved. So first, there's this massive sorting problem. You have many players, like you said, the MRFs, their claimers, are not even the same person. And you have this coordinated effort to sort and to reproduce this stuff, right? And then you have to look at those MRFs individually, and they have to basically take in a whole city's garbage. People don't know what they're putting in there. Even if everyone's recycling perfectly, you still got to separate your cans from your bottles, and that in itself is a huge challenge. So it's a really big sorting problem. There's the fact that what we consume, what we produce and what we consume is just not designed for recyclability. The big shocker to me when I kind of started on this path is there's that triangle and on your products, and when you see that triangle, it's like, oh, cool, this is recyclable, I'm in the clear. And it's just frankly, that's just not true. A lot of stuff has a triangle on it, but if your local facility can't process that, what the triangle really means is this in theory could be recycled, but if your facility, your city, your county can't handle it, it's going to landfill. And that's just the reality. It's this really irritating cognitive dissonance that consumers have because they think what they're doing is good for the environment. They think they're doing something solid. But at the end of the day, a Tetra Pak carton, a chip bag, these are things that just are not recyclable, and it's going to end up in the landfill. And finally, to top it off, it's really hard to educate consumers. It's really hard to be a consumer who knows how to properly recycle, how to properly deal with their stuff. I personally have been in the recycling industry for 2 years, and I still struggle every day with is this box actually recyclable? Well, there's like just no way to really clearly answer that. And that's because, again, it varies by what facility you have in your neighborhood and what the markets look like on that day of the week. So all of this together basically leaves this problematic space where less than 50% of the recyclables we could recover are actually recovered. And only 9% of plastic that we consume in this country is recycled. These are terrible numbers. Like, we should be able to do much better than this, but we're not. And this is exactly the space that we think there are just so many opportunities to do better than this, to increase in efficiency and get this to numbers that actually make us as a society sustainable, or at least look at these numbers at the bottom and be like, okay, cool, I'm happy with that. I think we're doing okay. Because I don't think anyone on this call is looking at those orange boxes and being like, yeah, that seems good. On top of the challenges that are there, we also are at an interesting spot in the market, in the industry, where there's a lot of pressure for this industry to get better. So I mentioned that China ban, right? Like, they stopped buying our stuff. So as a result, these facilities lost the ability to sell. And when you do that, you have to get more efficient. You have to be more cutthroat and figure out how to actually sell your stuff. In addition, these facilities are super labor intensive, which I'll get to in a second. When you're labor intensive and minimum wage keeps rising over time, it becomes harder to survive as a facility, whether you're a MRF or a claimer or anyone else in the chain. And finally, and most importantly, there's a lot of expected recycling to come down the chain coming from legislation. California recently passed a bill saying that producers have to have a minimum percent of recycled content in what they produce by 2025. And that's happening in a couple other states, and we're kind of seeing more legislative push. In addition, we're seeing companies like Coke and Unilever make sustainability targets that basically say we want to have this much recycled content. So you're basically at this point where everybody's expecting this industry to become better, to become more efficient and produce better, but they don't have the infrastructure, they don't have the technological innovation to do it, which again is why this is such an exciting place to be. That's why we're here. So the main problem we are starting with at Glacier is this problem of sorting. If you go into one of these facilities, what you're going to see that really shocked me is that picture on the left. There are people whose job it is to sort our trash. It really blew me away. I was like, cool, we almost got self-driving cars. I can like order a car to get from A to B with like a tap of a button. And like, yeah, we have people in facilities who sort our trash. This like seems like we're not doing the right by society right now. This is weird. In addition to it being kind of off, it's also really inefficient, it's really expensive, and it just results in a less efficient industry because as you have people, they don't like the job, they don't perform efficiently, they miss work, they quit work because it's a terrible job and they need to get rehired. You have all these gaps that make it really hard to do. So what we're basically starting with is like, how can we make sorting more efficient? How can we get these people into higher position jobs where they can actually provide better value than just picking trash? And so what we're starting with is a robot that uses computer vision to identify items in a conveyor belt like the one you see on the left, and robotics to actually do this sorting. The end goal, of course, being if we can reduce the cost to operate one of these facilities and increase the quality outputs, what we're doing is effectively increasing the economics and the economic viability of being a player in this recycling industry. And when you do that, you make recycling more attractive to businesses. More MRFs want to recycle, they invest more in actually doing it. And you have this nice upward spiral of infrastructure is getting better, the industry is getting better, there's less waste lost. We have less waste as a society, less pollution, all that stuff goes away. That's our vision, and that's kind of how we're attacking it. Questions?
Yeah, quick question. You mentioned how high China's new bar for recycling is. So, and that none of the MRFs can currently hit it. Do you think you can get it past that bar?
Yeah, I mean, there's certainly no reason, technically speaking, why we shouldn't be able to get there. There are facilities today that get pretty close to that bar. The number we're looking for is based on this number called contamination rate, which is again what percent of what we call like a ton of a commodity is not that commodity. And so their demand for the typical recyclable material is 0.5%. A good, really high quality facility can get somewhere between 1% and 3%. So they're like edging up there. Bad facilities, typically 10% plus. And as I mentioned, back when we were shipping off things to China, we were looking at numbers in the 20 to 30% range. So there are facilities that are edging up there. And so it is really a game we can actually get to that point and get to a point where, okay, China would be interested in this, which is not to say we got China back, but rather to say we are producing high enough quality output for this to be a marketable commodity, which again will drive the economics of recycling. Cool. So we do have our robots. I'm not going to show it to you right now because this is being recorded and we are in stealth. But I would love to show it to anybody here who is interested or anybody who's watching this recorded. If you do want to see our robot, we have it installed in the facility. It's picking as we speak. It's super cool. Every time I show it to someone, their excitement about what we're doing goes up tenfold. So I would love to show it to you, but I can't do it on a recorded line. Sorry. But if you email me and just say, hey, I would love to see the robot, I'll schedule a quick call to kind of show it with you, and we can, see how much you like it. I would love to show it to as many people as possible, but just can't do it here. Again, that's my email. It'll be obviously available after this. Feel free to shoot me an email and I will schedule a call to show it with you. The cool thing about what we're building is kind of this, and this is one of the main things I got into Glacier for, was that as we build these robots, which is a business win, right? As a business, we want to sell robots, but as we sell robots, our environmental impact just grows. So one robot for 1 year, what that does is 42 million recyclables diverted from landfill, which is the equivalent of 5,000 trees, 12.25 million kilowatt hours, or about 1,000 homes a year, or about 1,000 cars worth of CO2 per year. That's pretty cool for one single robot. We're really excited to see what 1,000 robots could do, because this is really the impact we need to be having on our environment to keep things in shape and keep us sustainable. That's kind of an overview of what recycling is, what we're doing as a company. I'm going to jump next into kind of some of the challenges we are facing and challenges that the recycling technology industry is facing. Before I jump into that, I'm going to stop one more time for questions. But if not,
I definitely got another one.
love it.
Just diving into this slide a little bit. So how did you calculate that equivalent? So you have the 42 million diverted from landfill, and is then you're calculating the methane emissions that are diverted, or what goes?
Yeah, exactly. So it depends on the commodity we're talking about. But if you just look at, for instance, that aluminum can, right? If you have an aluminum can that goes to landfill and you compare that scenario to the scenario where that aluminum can gets recycled, what is the energy savings there? What is the equivalent greenhouse gas emissions to produce that energy? And that's how you get those right too. Obviously, the trees are going to focus more on the fiber piece. If you're just sorting paper, you're diverting paper from landfill. That obviously is preventing you needing to go cut down new trees for more paper. So that's how these numbers come out.
Got it. And then with the 42 million, is that compared to like average MRF, or?
Yeah, so that's basically saying if you put one of these robots in and it's picking things off and keep it, if you put it in a place that is basically picking recyclables out of a stream that would be going to landfill, what is the number of things you pick over the course of the year? And that is, yeah, based on average run times of a typical MRF.
Got it. Awesome. Thanks.
Love the questions. Cool. So that's what we're trying to do, but we have this problem, and that is that building industrial robots is super hard. There are a ton of challenges, especially when you are a startup. Just kind of getting them out the door is really challenging, and that's where it's really exciting if you're into technical challenges. A few of the problems we have, right? You have to build machines for these facilities that are expected to last 5 to 10 years. But how do you build reliability into a machine when you're a startup? You got to move fast, you got to iterate, you got to figure things out on the fly. Figuring that out is a crazy engineering challenge that I think we're making great progress on, but certainly I will not be sure of that for another 5 to 10 years, which is certainly a challenge. We also are dealing with machines that move really fast. They're moving on belts that move pretty high speeds, and you need to be really accurate. So you have this whole realm of how do you deal with both high speed mechanics and high precision computing. That's another challenge on like the software and the dynamic side. And then at the same time, right, like robotic grasping, if you know anything about robots, one of the hardest things about matching human ability with a robot is the ability to pick things up, because the human hand is really just a marvel of engineering. And to do that with robotics, with mechanics, is super difficult. And so a typical robotic hand that can pick up, I don't know, a plastic bottle, it's not going to be able to pick up a fork. And so being able to solve those kind of problems at once is really evolving the bounds, the efficiency, the abilities of robotic grasping. At the same time, we have this computer vision problem where a lot of our computer vision today is being spent on self-driving, is going to be spent on facial recognition, and there's this whole domain of trash, of understanding the granularity and the distinctions between all of the types of stuff you might see in a facility that is really just outside the realm of what computer vision can do today. And so there's a lot of challenges on the engineering side, and we're also kind of pushing engineering forward just by being in this space. The craziest thing for me as kind of the founder is that the engineering challenges we face span a variety of disciplines. You can't just get one engineer who can handle everything, because you need to have expertise in software, electrical, hardware, you name it. There's a whole slew of things. And that's like just really hard to build for. And then on top of that, you have these facilities that are super unique. You can't just go build a MRF in your backyard, right? They're like very specific facilities. And so testing machinery is really difficult to do unless you go install and use that facility as a test facility. But if you want to run beta tests or unit tests in your lab, it's really hard to get everything right, because it's hard to predict what might happen. A great example of this is that robot we have. We were picking basically, pieces of plastic off of a line. And one thing we just didn't know would happen is basically once or twice a day, a kitty litter box. So basically imagine a 14-inch by 14-inch by 16-inch tub that's big and yellow and rigid would come through. And we had never seen one of these before in our scoping, but you design a machine to be picking bottles, and all of a sudden there's this like 14-inch by 14-inch thing rolling down the belt. It causes chaos, right? And like, if you don't know what that chaos is when you're designing, it's really hard to predict, to design, to test your machinery for that sort of stuff. We did solve that one, but it definitely causes a couple of broken machine arms along the way. I'd like to share like a little example with you guys to kind of go into, okay, why is this so difficult? Here's a quick engineering example for anyone here who has a technical mindset. Let's say you want to pick an item off a belt. It's moving down the belt. You have a little robotic gripper. Your objective, of course, is to go find that item, make contact with it, and then pick it off the belt. But there's all these variable conditions that happen every time that you go for a pick. The thing you're picking, right? Is it a bottle? Is it a can? That changes per pick. The size of it, the height of it, right? How far do you have to press into it? How squishy is it? All of that, again, variable per pick. And then the weight of the item, right? Is it an empty bottle? Is there some liquid in it? Is it an aluminum can? Is it something else that's metal? Again, variable things. Every time you have variables, it's hard to design engineering components that can handle a variety of things. In addition, the belt speed is not guaranteed, because the belt is run by a AC powered motor. So as voltage fluctuates to that, the actual rotary speed of the belt changes by small bits, and that makes it harder to make sure you have accurate contact. The item's not guaranteed to be static on the belt. It can roll, it can get hit by things, wind can blow. On top of all of that, there's computer difficulties, because when you have a lot of complex things happening in your computer, you have to deal with computer response time. How fast does it actually process? You have to deal with serial communication time. How fast can you actually communicate from your camera, which communicates over USB, over Ethernet, whatever it might be, to your computer? And that, again, is variable. So all of these things are variable. To solve this, right, you have these tons of problems. It seems so simple. I want to go make contact with that thing, but all of a sudden you need expertise across computer vision. You need expertise across software, firmware, microcontrollers, low-level OS so you can understand USB channel communication. You need electrical engineers to make sure that your wiring is reliable. You need to understand motor controls. You need to understand how to actually speed the motor up at the appropriate speed so that it can actually make contact gently with the item rather than smashing it or smashing your arm. You need to understand mechanical dynamics. How do the components of the robot interact with each other when you make contact with the item on the belt? How does that affect the longevity or the stability of your robots? And then obviously, if you're doing this over the course of years or months or weeks even, how do you ensure that every pick will work? How do you ensure that things are not wearing, and make sure that, for instance, the belt that you use to drive your mechanics isn't wearing, isn't stretching, whatever it might be? You can see with this relatively, well, hopefully not that simple example, you need expertise and you need pretty solid thinking across a variety of engineering disciplines, which is a really interesting collaborative problem to make things work really well. And that's just one of the problems we have I mainly put this in here to get people's juices flowing because, yeah, this is not an easy problem and not something that's necessarily solved by basically anybody at this point. And so it's a cool problem to have, but hopefully we'll figure it out. In
Just
addition
to
to that,
add to that quickly,
yeah,
is there do you often have objects layered on top of each other?
of course, all the
Like,
time. Yeah, you'll oftentimes see a plastic bottle on top of a piece of cardboard or on top of something else. You oftentimes have a plastic bottle underneath a clear plastic bag, and so your computer is gonna be like, hey, look, there's a bottle. It'll go to get it, and you'll actually get a plastic bag instead. There's all sorts of issues in terms of layering, and there's also the problem of like, okay, cool, like here's a mountain of stuff, and there's a plastic bottle underneath. Like, what do you even do in that situation, right? How do you even get that bottle out from that mountain? And again a ton of challenges. This one specific to a robot, but like just generally speaking, making sure that you can actually see every single item and sort it appropriately is a monumental task. And that's a really good point. In the industry, we call that burden depth, which is the height of stuff on your conveyor belts. In addition to kind of the ones we're kind of throwing out, a couple other challenges that we have to figure out, both on the technical and non-technical side, is how do you pick oddly shaped items, right? So a bottle that's just like smushed flat, great, easy to pick. But what if it's crumpled and in a weird zigzag formation? What if it's torn? What if you have to pick a straw or a napkin? All of this sort of stuff that is, again, not easy for robots to deal with. And then how do you all do it with one single robot, right? How do you actually get one robot that can pick both bottles and straws? Because that might be the need. There's a kind of identification, a data problem. How do you classify everything? We need to have an understanding, of course, in both this application of robot on a conveyor belt, but also as a society, understanding what is actually getting thrown away so we can actually be actionable. A lot of companies like Coke and Unilever, for instance, are really interested in knowing where their stuff is ending up, but to actually classify all of their pieces is, of course, a challenging bit of both computer vision, data, and also just kind of figuring out how you want to divide the set of trash you see and what you want to go after and not. Recycling waste generally is a pretty old school industry. They've been doing things the same way for a while. There's new technology that comes around every once in a while, but a lot of facilities, they see robots and they're like, ooh, that seems risky, I don't know. And so we also, again, on top of the technical challenge, have this like sales side, this business challenge of how do you make them adopt it? How do you convince them this is a good technology or reduce the risk of investing in this sort of technology, especially as it is developing? We all know the technology will get better in 5 years, but how do we convince an industry to start being more aggressive with this stuff? Because we need this sort of technology today, and if we wait 5 years, we'll be 5 years deeper in the hole. And finally, uptime is super key for this type of facility. So how do you develop a machine that's complex, sophisticated, but also easy to maintain? There's a classic problem within engineering is building something complex but simple at the same time. And that's something that we're certainly focused with as a challenge. So yeah, we have a lot of challenges, a lot of cool stuff. I would be a terrible CEO and founder if I did not put this slide in here, but we're also, hey, look, hiring. So if you think those challenges are cool, if you think you could solve them for me and you don't think they're cool, but think you could help anyways, I would love to chat. We're looking for a senior software engineer, a robotics engineer, an electrical engineer. And frankly, if you think you could help in some other way, but you're not one of those three, we're open to that discussion as well. Here's my email again. You've seen it before. You'll see it here. It's Agreed, my first name at endwaste.io. Shoot me an email if you or someone you know is interested in helping tackle these problems. Or if you just want to learn more about stuff. I love talking to people who just want to get involved or just understand the recycling space, the waste space better. I'm always happy to chat with new people. So feel free to shoot me an email and I would be more than excited to chat. I have no further slides because I did want to leave a lot of this open to Q&A. So with that, I will wrap up my spiel of just monologuing and let people ask whatever questions they have.
Amazing. Thanks so much, Reed. That was awesome. Yeah, so anyone can definitely feel free to unmute yourself. If you want me to ask a question for you, you can post in the chat. And I will. Maybe I'll kick it off with one question while I'm here. Just going back to these extreme challenges you're facing as the items are coming down the conveyor belt. How often do these like extreme challenges come? Like, are they like edge cases or yeah?
Yeah, I mean, it kind of spans, right? So the most basic thing we do is make contact with an item. So that example I showed, that is the bread and butter of what we have to do, and that in itself is a challenge. But in terms of the diversity of the belts, in terms of having to pick up things that are a little bit odd, it's pretty frequent. It's you can just imagine a perfect world where like everything we threw away in the recycling was only plastic bottles, and our job was, I don't know, to pick up like just the green plastic bottles, right? Like even in that world, just like the number of ways a plastic bottle could be contorted is literally infinite. And the ways that things could be overlapped on each other, again, literally infinite. So that challenge is constantly present. And you're basically always seeing it. And now let's add the complexity. Of course, like not everything in our recycling bin is plastic bottles. There's a lot of stuff that shouldn't be in there, but finds its way in anyways. And you have to deal with that basically on an ongoing basis.
Right. Got it. And I guess the reason I'm asking is if you look at maybe the most extreme challenges, like you were talking about having a plastic bag on top of something else or whatever, is it worth it in your early iterations to just like divert that to human sorting? And then you still get like 90% of the benefit of the machine, but in those like very extreme cases, you still have like a small line with a few employees.
Yeah, it's a great question. You're kind of asking about how do you design a MRF, which is totally a topic up for debate among MRF managers. The general lay of the land is you have what's known as the pre-sort line, and they do exactly what you said. Their job is basically to take out the things that the machines cannot handle. There are other machines in these facilities. They do a lot of sortation using kind of more archaic technologies, density separation, et cetera. Big magnets that can pull out like, ferrous metals. They work great. They're kind of what I call high quantity, low quality sortation, but they also fall susceptible to some of these things you mentioned. So for instance, if you have like a blanket put in the recycling bin and it makes its way to the facility, like a person needs to remove that blanket before it gets to one of these machines that has like a big spinning wheel, and that blanket will just like jam it up. And so there's these people, they do pre-sort, you have other machines, you have QC. It kind of depends how you as a facility want to design how your flow works. But you're totally right. You do want to have people who take these like really hard to process items out of the way and leave it more ready for machines to handle the tail end. But again, like, why are there people there? Like that seems like something that you should be able to automate anyways. And again, it's like, it's not a good job to have to pull out people's dirty blankets from trash. And so when I look at that, I'm like, okay, cool. I see that as a technical challenge. That's another form of robotics, or at least another form of, industrial machinery should be able to handle on its own.
Awesome, thanks.
Hi, Arif. My name is David. I just thank you so much for this very informative presentation. I was a little curious whether Glacier's robots are they intended to work alongside human workers in MRFs, and are they concerned about safety of their workers in the presence of your robots?
Yeah, great question. That's a big question inside robotics generally. So one of the things that we are really proud of with our robot is we designed it with kind of the MRF in mind. We went to ask them how they feel about machinery, et cetera, and started with that. And one of the things that they were, of course, worried about is, I don't want a robot that's going to, harm my people. I don't have enough space to like give your robot a whole 100 feet of space or whatever. And so, yeah, our robot is designed to work very close quarters with other people. There's obviously like some safety precautions you need to take to make that happen. But that was definitely incorporated into our design, and MRFs are super excited about that. That being said, there still are safety challenges. For instance, what happens if a person, because if your robot's sorting, you need to have some area of contact where your arm can get, but also items can come into, and that implicitly implies that a human hand, if it wanted to, can sneak its way in. When you're talking about industrial safety, you always think, what would someone who is intentionally trying to hurt themselves do, and how do you protect against that? And those are, I didn't even list that challenge. It's a great one. I'm going to put on my next slide deck. Like, how do you design the machine to be safe for literal people who want to hurt themselves and make it impossible to do so. Something we got to work and figure out.
Awesome, thank you. I hope I'm not going, if there's anyone else that wants to ask a question, please feel free to speak up. But I did have another quick question, Arib, and that's just related to how granular the sorting needs to be for the MRFs, meaning, in one possible example is just say a bottle that has the same shape, but could be either plastic or glass. I'm guessing that the computer vision algorithm needs to be, it needs to be able to distinguish between the different types of materials. But then perhaps even more granular is different types of plastic bottles or different types of plastic materials. So a PET material compared to another type of plastic material. Is that needed for MRFs to accept this type of offering? Please go ahead, sorry.
It's a really great question. And I sometimes forget the difficulty in handling recycling. You know, the triangles on your plastics, there's like 1, 2, 3, 4, all the way to 7, right? That in itself already kind of shows why this is complicated. Obviously, those numbers, they don't mean anything to us consumers, but they do mean something to people who recycle. And if you are a reclaimer and you want PET bottles, that's triangle number 1, which means you do not want any triangle number 2, 3, 4, 5, 6, 7 in your bales. And so, yeah, that kind of granularity is very much needed. It's kind of defined by the industry, right? So if there is a reclaimer who wants to buy triangle 1, and that reclaimer is okay with having triangle 2 mixed in there, then you as a MRF are allowed to produce that bale. But that's kind of up to the technology available at the reclaimers. Can they handle some triangle 2 in their triangle 1? And that depends on the manufacturers. And you have this whole, nice circular economy, as they call it, saying this is something that we need sorted because we cannot produce. Now, typically speaking, that granularity is kind of what we described as like triangle 1 needs to be on its own. And so if you have 2 bottles and one is triangle 1 and one is triangle 2 and they visually look identical, yeah, I got another challenge for you. How do you distinguish those two, right? If they look the same, but they're actually different plastics, we need to be able to sort that apart. And that is a common challenge that we have to deal with.
Awesome. Thanks, Arib. You were talking about these pre-sorting machines. So you have the magnetic machines that they'll grab up the steel, whatever, et cetera, et cetera. If I was to start a new recycling facility today, and your machine was fully realized, would you say that I could replace those pre-sorting machines, or would this be complementary?
It's a great question. And I would actually ask you to take it one step further than that and say, if you were to design recycling from the ground up, what would it look like? The vision of a fully automated or fully built from scratch facility. Yeah, I think you're absolutely on the point there. Is could you basically design it with these machines, or maybe even with machines that are nothing like this, to not require any human intervention at all and be really efficient and really cheap? That's at the end of the day, what matters is, can this thing be affordable? Because at the end of the day, as a producer, you want to produce using whatever is cheapest, maybe with some sustainability leverage baked in. But if you can get things to be super cheap, that's the goal. So if you're building a brand new facility, the question is, what technology do you use, or what do you even design your facility to do? And that's like a great question. So like one of my favorite questions to dwell on is, let's say that there were no facilities at all and we were inventing recycling. Would you even do pick and place? I wouldn't, right? Because this idea of having to pick an item off a belt and move it somewhere else is a little bit like, it's playing to what's already there. But if you didn't have an already there, you totally wouldn't expect to like solve this incredibly hard challenge of like robots matching hand abilities. You would just get rid of that entirely. And so if you could redesign things from scratch, I would imagine it would look entirely different than how it looks today, because we do have a lot of technological advancements that have been made since recycling industry started, or recycling facilities started popping up. And so, yeah, I think it would look totally different. And it's really exciting to imagine. And maybe even one day build what that could look like.
Love it. And I mean, in general, out of curiosity, are there new recycling facilities popping up, or is that pretty rare?
As you might imagine, it happens pretty slowly. They do happen, but the timeline between getting the idea rolling with your city and actually closing like, the final circuit and getting things running, it's dozens of years. So it takes a while to get that stuff up and running just because it's
Right.
such a complicated project.
But that might be very different in other parts of the world.
How do you mean?
Like in other parts of the world, if they don't already have this recycling system in place, then maybe there
Yeah.
is an opportunity to.
Yeah, and again, like that's one of the things that I think when we do our work, we focus a lot on the US, but the reality is a lot of the waste that we have to capture as a society comes from places that just like don't have recycling infrastructure, right? My family is from Pakistan. Every time I go to Pakistan to view it, there's not even trash collection. People take their garbage out to the street, they burn it because there's nothing else to do, right? Like,
Right.
okay, let's see like what would it take to build or like produce a facility that's so cheap and easy to get set up that you can just like do it in a year. All of a sudden you have a recycling facility, or at least some sort of trash handling facility that you can install in places that otherwise wouldn't be buying it. Right now they're not buying it because the economics don't make sense. But if you can start making those economics make sense, you can start incentivizing cities like where my family came from to start actually investing in this kind of infrastructure and preventing the pollution that's causing so many issues.
Totally love it. And so Glacier seems awesome,
Oh, thank you.
but let's say you're not allowed to work on Glacier. What would you be doing to fix recycling otherwise?
Well, there are a ton of problems in the recycling industry that I kind of mentioned. If I'm just focusing on like waste as a problem, what are the other things that you could do? There's the consumer side, right? One of the things that's like most valuable for these facilities is if there's like not stuff that shouldn't be in the recycling bin in the recycling bin. The most common now like kind of common item you see that always causes problems is Christmas lights in the months after Christmas, which are terrible for all machinery. They just get wrapped around everything and ruin all sorts of stuff. Let's just imagine you could like prevent Christmas lights from making it into the recycling bin. That's like already a big win. So focusing on consumer education or making it really simple for the consumer to actually sort properly is like a really great way to make an impact. Number two, I would say focusing on is reducing the amount of stuff that needs to be recycled, right? Most people that I am friends with now have, a steel or a glass or like reusable plastic water bottle that just like eliminates my reliance on plastic bottles to begin with. And the further we can push along that train, the better. There's also like the realm of like, biodegradable plastics, right? If you can build that up. Obviously the composting industry is like a very, very novel one that like has a lot of ways to go, but there's a lot of, value in that lever. There are kind of business plays because the economics between these players doesn't quite make sense right now. This might not surprise you, but there is no Amazon for buying bales of PET, which means it's really unclear how much stuff costs, where to get it from. Those are problems that exist. Just all the way along this chain is just not a space that people have been thinking about. So if you're entrepreneurial, I totally encourage you to just like take a few days to go look into the recycling industry, and I guarantee you'll find a cool business idea in no time.
Love it. We probably have about 5 minutes left with questions, and then we'll wrap up. If anyone else has questions, please, I'll keep plugging away. But if you have a question, either interrupt me or raise your hand or post in the chat. But yeah, Ariba, I have no idea if you have any concept of this, but you mentioned biodegradable plastic. Do you have any sense of if you compared the environmental impact of a biodegradable, say, plastic cup to a recycled one, which would come out on top?
Oh man, you reached the edge of my domain. I do not know the answer, but I'm dying to go look it up and find out. Yeah, it's my optimist in me wants to say that yeah, of course it's better because like why would we be producing these biodegradable cups if they're not? The pessimist in me sees how duped consumers have been by the recycling just concept over the last several years, where you see a little triangle on a thing that's totally not recyclable and you feel good, therefore you do it. And so I could totally also see the pessimistic outcome being like, yeah, those are just terrible for the earth too, and we're just like, oh yeah, these are compostable, great. I really hope that's not the case, but I do not know the answer.
Yeah, and I guess I feel like my question was kind of done because of course there's so many different feedstocks for biodegradable plastic, etc. I guess I was probably asking like in the best case for each, but that's our homework for after this.
That's our homework. That's our homework. I mean, the reality is like if you can compost a thing versus recycle, it's so hard. I don't know. I'm not gonna try to say anything here. There's too many people get misinformed.
Fair enough. So why the name Glacier?
Why the name Glacier? Great question. One that actually my co-founder and I debate about a lot because she totally doesn't like the name. But I named it after Glacier National Park because, well, I mean, the implications are very clear. The big drawback to the name Glacier is like glaciers move super slow and they're dying. So that's kind of weird. But I think like the point was we want to show this recycling industry. We want to give out the signal that we are a mission-oriented company. The name robotics is not in our company name because we're not here to build the robots. We're here to end waste.
Right.
We're here to solve this waste problem. And the reason for Glacier then ties into that, right? We want to indicate to people that we're not robotics. We're not here to build tech. We're here to just kind of figure out how to save the earth. And obviously we're focused in the waste space, but the general feel is let's focus on nature. Let's focus on the planet. And kind of keep our focus no matter what happens on making sure that our company is doing best for the climate and nothing else.
Love it. Awesome. And Cal, go ahead.
I have a quick question. Basically, yeah, I think what you're all doing is really cool. You've kind of got this really narrow scope. But is there something else within the kind of the end waste domain that you're not focused on, but that you're still really passionate about, and you wish somebody else is attacking that problem?
Yeah, there are also, I kind of mentioned a couple of them that I would like to see people working on. There are other challenges, of course, with kind of like the hauling aspect. If I jump back to like kind of that earlier slide up here, like basically every arrow and every block, like every edge and every node on this chain like has an issue that needs solving, and I would love to see worked on. One of the problems that we kind of are working into, but I would love to see more understanding of, is just like, this is a cute little chart, but there's no data behind this at all. The data in this industry is just totally missing. And we've seen big data do so many transformational things to so many industries. If we could get like kind of that big data solve to recycling, to just like waste in general, I think there would be a lot of value in that. I've already talked to a handful of nonprofits, municipalities, people who would be like, yeah, I would love to know how much trash is coming out of this MRF and what the composition looks like. But it's not being done right now because it's really hard. But I would love to see that solved as well, because I think just understanding the problem will help us identify where the inefficiencies are that we can actually attack.
How did they even get the first, like you said, all these facilities have like a percentage of recyclable waste versus non-recyclable waste. Like, how did they even get that number?
Oh, it's terrible. My co-founder actually went to the San Francisco recycling facility a few days ago to watch them do this. What they do is they take what's known as a bale, which is again a cubic meter of just like some material they think it is. They take that bale, they shake it out onto the floor, and then they go and they walk through and they pick out the stuff that shouldn't be there. And they do that like every once in a while and say, oh, okay, our bales are like approximately like 4% contaminated. I didn't do a great job counting, but like, hey, that's it. So yeah, I like where your eyebrows are at, Cal. It's like, that's the appropriate response.
Well, thanks a lot.
For sure.
All right, great question. We probably have time for one more question if anyone has the last one. If not, I'll ask one. All right, my question for you is, on one of the first slides, you held up a few really motivating reasons for why someone might want to tackle this problem. Yeah, you have pollution, GHG emissions, and there's probably, I mean, even more. There's like in developing countries, there's people who are, yeah. So I was just curious if one of these in particular stood out for you as like the main motivating factor to get you out of bed in the morning.
I think for me, the pollution is the most tangible, right? Like we have this huge, very visual, very visceral problem that is like take the Great Pacific Garbage Patch, for instance, right? Like it's crazy that we've developed that. Like what a ridiculously phenomenal, terrible thing for society to have built. It's like an island of trash in the ocean. And like it's, of course it's going to get worse. Our reliance on plastic is expected to, you know, grow massively in the next 20, 30 years. And the fact that like that pollution not just represents pollution, but represents a missed opportunity, represents waste in its like the purest form of the word, right? That was something that we wasted. We could have done something with that we didn't. I think that is like fundamentally what's like most troubling to me. Obviously, there's a lot of other stuff baked in, but that one I think is the most visceral.
Awesome, love it. Great. Well, Reed, thank you so much, dude. Do you have any last words for us?
Well, I can just go back to the last slide again. Come join us. If you know someone who does, this is how you reach me. I would love to chat. Also, if you're just interested, yeah, chat as well.
Amazing. Thanks so much, Reed. This has been awesome. I'm going to make a post on the Events Wackle channel where everyone can post one thing that they learned about the talk, if there's something that stood out to you, and we can flag it for other members of the community. And yeah, Reed, thank you again so much. Thanks for everyone for attending. And yeah, this has been awesome.
Thank you, Sam. And shout out to David and Cal for asking questions.
Awesome. Thanks a lot, guys. See you all.
Bye.